So this is question 5 off of the sheet that I handed out in class today. So we're trying to find the area of this region, right, this little swoopy pie region between these three graphs, y equals x, y equals 1, and y equals x squared over 4. So if you look at the ways that we could potentially draw our rectangles, right, we could do vertical. Oh, something happens though. Notice your vertical rectangles over here between 0 and 1. Oh, you might want to verify all of your intersection points there. Between 0 and 1, right, the top function is the line y equals x, and the bottom function is y equals x squared over 4. But between x equals 1 and x equals 2, the top function is y equals 1, and the bottom function is y equals x squared over 4. So you could break it up and do it as two separate areas if you did vertical rectangles, or if we do a horizontal rectangle, which I'm going to sketch in, if we do a horizontal rectangle, right, then the left and right functions stay the same all the way up and down. Okay. So I said I wanted to show you this because it caught me up. So if I do a horizontal rectangle, then I know I have, right, it's a little chunk of y. Okay. But when I go to find the height of that rectangle, right, I need the x value all the way over, and I need the x value, right, on the left function. So I need the x value on the right function and the x value on the left function. So when I went to do it, I put in my x function, right? I put in x squared over 4 minus x. But that's not it. So I had this. I had x squared over 4 minus x. So the function on the right minus the function on the left. But the reason why I said, oh, well, that can't be right, is I'm integrating with respect to y, but all I've got are x's here. So that was a clue to me. Oh, that's right. I need the x value there, which means it's the y function, right? So this was easy enough because that's just the line y equals x, so the x's and the y's are the same. For the first one, though, I had to go back and solve y equals x squared over 4 for x. I needed x equals. So 4y equals x squared. X is 2 radical y. Yeah, I know plus minus, but we're in the first quadrant. So just the plus. So I have 2 radical y minus y dy as y goes from, well, y's I add up from y equals 0 up to where y equals 1. Okay. So if we do that integral, so I'm going to hop over here. So integrate 0 to 1, 2y to the 1/2 minus y dy. Use our power property. 2y add 1 to the 3/2, divide by the new. 3/2, multiply by 2/3, minus y add 1, divide by the new. Between 0 and 1. So what do I get? 4/3 times 1 minus 1/2. When I plug 0 in this time, everybody's a 0, so they go away. So 4/3 minus 1/2. So what do we get? 8 minus 5, 8 minus 3, so 5/6. So that's the answer I get for that one. Hey, just for grins, since I've got a couple of minutes here, let's make sure we would get that same number. Oh, I'm tempting fate. I'm totally tempting fate here. Let's do vertical rectangles, break it apart, and make sure we get that same answer out. With vertical rectangles. Y equals x, y equals 1, y equals x squared over 4. So this point over here, what did I have? 2, 1. X equals 2, y equals 1. This is my 1, 1. 0, 0. Grab a different color so you see what's going to happen in here. So I'm going to find this left area with one integral, and then I need to find the right area with a different integral. And I'll change colors so you can see, and we're going to keep our fingers crossed. Okay, so with my vertical rectangles, I have dx. So the orange area, area 1, right? My little amount is in the x version, so I have a little chunk of x, dx. I'm only going for the orange from x equals 0 till x equals 1. The function on top is the line y equals x. So this is the dx. I need, write the y value, known as x, minus the bottom y value, known as x squared over 4, with respect to x. Add 1, divide by the new. Add 1, divide by the new. Between 0 and 1. So this is saying that A1, my orange area should be, let's see, 1/2 minus 1/12 minus 0. So 6, 5/12. Now we would do the second area, so now the green area. So that time my x's, so again, right, another vertical rectangle. So dx, right, the width is a little chunk of x. I'm adding those up between x equals 1 and x equals 2. Now my top function, the y value, right, is 1. The lower y value is x squared over 4. Integrating using the power rule. So what do we get? X, integrate 1, you get x, minus x cubed over, divide by the new, make sure you get a 12 down there, between 1 and 2. Okay, you guys know this is where I'm going to lose it. Plugging in with the numbers, what do we get? 2 minus 8/12 minus 1 minus 1/12. So I'm going to get 2 minus 8/12. Sometimes I just leave those decimals in because nice things happen after I combine the two parts, because usually I'll have the same denominator and sometimes it becomes a whole number. Trying to still get just a single number here for my second area. So I get a 1. Well, that's not nice. 1 minus 7/12. Okay, fingers crossed. Are yours crossed? Mine are crossed. Total area. If I add up my orange area and my green area, hopefully 5/6 comes out when I do that arithmetic. A total. So 5/12 from the orange plus 1 minus 7/12. Oh, that's 5/12 too. Yay! So however you get there, 1 minus 2/12, 1 minus a 1/6, 5/6. Yay! Okay, so either way, but one was definitely easier.